Our 10th problem is a very important problem in which we are required to find the sum equal to NC0 minus 2 square NC1 plus 3 square NC2. We need to find this sum. This is a very important and a very interesting problem which can be very easily solved by using just the simple expression of 1 plus x power n is equal to NC0 plus NC1x plus NC2x square up till the last term. Now what we need to analyze is this NC0 is having 1 whole square term along with it. This NC1 has 2 square along with it with a negative sign. This NC2 is having 3 square along with it. Now what we do is we try to analyze how we can bring this 3, 2, 1 and so on in front of this NC0, NC1 and NC2 terms. First of all, check by differentiating, can we get these 3, 2 and 1 terms along with these? Let us differentiate this. On differentiating, we get n into 1 plus x power n minus 1 is equal to 0. Now this NC0 is getting equal to 0 and we need to find NC0 in our given expression. So this method is definitely wrong. Now the next term will be equal to NC3 x cube and we need to have a 3 in front of NC2. So what we can do is we can convert this x square into x cube. Then on differentiating this x cube, we can get a 3 in front of NC2. So what we can do is we can multiply both the sides by an x and then try to differentiate the whole equation or the whole expression and try to find out whether we are getting a 3 or not. So on multiplying both the sides by x, we get x into 1 plus x power n equals NC0 x plus NC1 x square plus NC2 x cube and so on. Now on differentiating both the sides, we get, using product rule, we get 1 plus x power n plus x into n into 1 plus x power n minus 1 is equal to NC0 into 1. We have got one of the ones which we required to prove. We want one more one plus 2x into NC1. We have got one of the 2's in front of NC1. We just require one more 2 in front of NC1. So definitely this method is correct as it is leading to our answer. Plus 3x square into NC2 and so on. Now we can again see we have got one of the 3's in front of NC2. We now just want to bring on one more 3 in front of NC2 in order to prove our answer. Now rewriting the whole expression again, we get 1 plus x power n plus nx into 1 plus x power n minus 1 is equal to NC0 plus 2x into NC1 plus 3x square into NC2 and so on. Now in our original expression which we wanted to prove, we had one more 3, one more 2 and one more 1 in front of NC2, NC1 and NC0 respectively. So what we can again do, we can again multiply both the sides by x to get NC0 into x plus 2x square times NC1 plus 3x cube times NC2. Now if we differentiate both the sides as we did earlier, we will try to find out whether we can generate a one more 3, one more 2 and one more 1. Now differentiating both the sides again, we get 1 plus x power n plus x into n into 1 plus x power n minus 1 plus 2nx into 1 plus x power n minus 1 plus nx square into n minus 1 into 1 plus x power n minus 2. and we get NC naught plus 2 square x NC1. So we have generated the two 2's required in front of NC1 plus 3 square x square NC2. We have generated the two 3's also in front of NC2. So our job is almost completely done. Now in the given expression which we required to prove, there was no term of x, and the sign in front of 2 square into NC1 was a negative sign. So what we can do, if we can put x equals -1, we can get the desired result. So putting x equals -1 in the LHS, this is gone, this is gone, this is gone, and this is also gone. So in the LHS we get 0 equals NC naught minus 2 square x equals -1 into NC1 plus 3 square into NC2 and so on. And this was exactly the value or the expression whose value we wanted to find out. So the value of expression NC naught minus 2 square NC1 plus 3 square NC2 up till n terms is equal to 0. So here in this question we saw a very important approach of differentiating both the sides of the binomial expression to get a result, or multiplying both the sides of the binomial expression by an x and then differentiating both the sides to get a result. So these are some of the general approaches which we use in the binomial expression questions, and our final answer is NC naught minus 2 square NC1 plus 3 square NC2 going up till n terms. The value of this expression is equal to 0.